flowy. There we go. Okay. Whoops. All right, let's stream. Let's stream. Keep it short and sweet today, I think, but I think it's still a good idea to do something. All right, so I've been messing about with surfaces and constructing surfaces from different curves. I'm trying to figure out, there we go, if I'm doing things in a sensible way. That's really what I'm trying to do. I want to, okay, so I think the goal the goal for me for the day is to try work with the idea of this here. So taking a UV surface and mapping the UV coordinates in such a way that I can get surface patches from a nice 2D drawing kind of wrapped onto the surface for the purpose of doing a kind of cylindrical surface thing. The trick is, or one of the tricks I'm trying to figure out, is how to define the region of the surface contained within the curve. So I can draw shapes in UV space and project them into 3D space via a surface. That's not that difficult, but well, I mean, there's going to be edge cases to it, but the real thing I'm trying to figure out is how to properly, excuse me, properly get, yeah, just this subsection of surface, and I'm not entirely sure how to do that, because it's not obvious to me how I would do it. That's really the moral of the story here. I mean, I can get the curve, split the curve any number of ways, and create... Actually, now let me think about this. I wonder... Let me think about this. I don't know. maybe I won't worry too. Let's start with. How do I want to do this? I think it'd be cool to build some mechanism that lets me define an SVG drawing and then project that SVG drawing into a UV coordinate space, so at the very least I can get 3D curves, and then I'll worry about creating surfaces and stuff and meshes from those 3D curves later. I think if I get the pipeline in place where I kind of UV map a 2D drawing onto a 3D surface, that seems like a pretty sensible place to start, honestly. I feel like that's a good idea. Can't really go wrong with that. At least not initially. I feel like that makes sense. How is everyone doing, by the way? I hope everyone's doing okay. I'm doing okay myself. Had better days, had worse days. Kind of right in the middle of it all, you know? Let myself get distracted. One of those distracted kind of days. It's been a weird start to the week. I mean, I've gotten some good work done, but I've felt distracted during the day. In the morning and the evening, I've gotten good work done, but the middle chunk of the day has been off. But you know what? I'll take little bits of productivity where I can get it. I'm not going to be too hard on myself for that, honestly. Alright, yeah, so let's do... Well, let me explore the creation of curves just a little bit further yet. Let me think about... Let me get back to... Forget what I was attempting to do. Let's just start with this anyway. This should be that sort of cone-ish looking thing. There we go. Oh, it's much smaller surface than I thought. That's okay though. Not a problem at all. So if I had a closed face on this bottom part here, this would actually be a valid solid. There's nothing. I mean, I'm quite sure that even right up to this exact point, it's a perfectly manifold shape. It's not like pinching in on itself. It's exactly, yeah, that seems pretty good. All right, let me see here. I'm just thinking about how, maybe I'm overcomplicating things, but I'm realizing the way that I'm kind of building surfaces and the assumptions I'm making in even this function here might be incorrect for surface along, where I'm just doing, I'm not doing a full no, I'm not going to worry about it. Let's just make the assumption that things are okay for now. Right, that'll be okay. Let's make a new surface with two functions, but the function here is a function of t returning 0, 0. And now this, let's make this just 50. Okay, that should be a valid circle surface. Yeah. Honestly, a bit hard to see it. It looks really good though. Let me see. The cool thing about this approach, well, let me see what this looks like. You know what? Let's bump that up to 20. That's pretty good visualization wise. Although let's do 16. Yeah, I'm fiddling around with numbers that don't matter. Let me redef A again. If I make it 10, no, 50, like this, it is still valid. Okay, that's really good. Okay. Part of me is wondering if I can actually use this parametric surface approach to make some well-behaved triangulation algorithms for use in, like, even in the 2D cases of things where you might want to use something that's not quite the ear clipping algorithm. There's maybe something to that, honestly. Because what I can, let me see. Hey, C-Films, good to see ya. Glad you're doing great. How am I doing? I'm doing okay. I am feeling pretty good about my CAD work that I've got going on here. I'm excited. I have a programming job interview tomorrow. I'm excited for it and a little bit nervous, but I think either way it should be good. Yeah, that's how I'm feeling. Okay, so here you get malformed, like a malformed surface here, which is not too surprising, honestly. Although let me, I'm curious now. If I do that, oh yeah, it does make a 3D cone. That's cool. All right. You want to add more data viz tools? Yeah, what kind of visualization stuff are you hoping to do next with McFly? You can never really go wrong with more visualization options. It's always useful, I think. Oh yes, that worked too. Perfect. Great. What type of tools and equations do you use a lot for visualizations? Well, I mean, for me and the work that I do, I've been almost exclusively in 2D, 3D graphics. So my really rough tools that I use are things that'll generate PNG images and vector-based things. So, I mean, as is pretty clear at this point, SVG is an example right here. And 3D mesh renderers and mesh viewers. For example, here is OpenSCAD is a common one that I use. I mean, in terms of data visualization, you might use stuff like D3. I mean, if you're interested in more visual stuff, have a look at the features that Jupyter Notebooks provides. Jupyter Notebooks are quite a good way to do, I mean, all kinds of visual stuff. You got R, Ruby, C++. Ooh, I didn't know they had C++. That's cool. They have Scheme. That's nice. Integrated with Python. Oh yeah, I remember this. So any kind of features that you'll find in Jupyter are at least a good example starting point for what people might expect to see in similar tools, you know? So let's see, does this even have... Okay, this has the words display. Let me try to run this whole thing and see. I'm sure there's a way to run the entire thing in one go. Oops. Okay, so it looks like they're all being calculated right now, so we just gotta wait. But here, I'm curious what this will do. Display and print line. I'm a little curious what that'll look like. Oh. Uh-oh. Oh, never mind. That's normal. Hello from C? Wow, that's amazing. This is cool. Okay, we got outputs, method error, of course. Oh, see here, look at this. See, this is interactive plotting in iJulia. Like, if you look at this, right, you can, so, using our data sets, I mean, that's pretty cool. You've got a nice formatted table, even. These plots are, the calculation's taking its time, but anyway, that's no big deal. I'm quite sure it takes its time because this is like a free low-powered server that's running, so it's not necessarily gonna compute things quickly. But there's also D3 is a very powerful tool. If you could integrate with that somehow, I'm sure people would use that. Like, look at this. That's pretty cool looking, if I do say so myself. Voronoi diagrams. Beautiful stuff. Man, oh man. Oh yeah, Observable is another computing notebook platform. Maybe poke around on there too to see what features they provide. All kinds of useful stuff. Oh, look at that. There's a plot. There we go. Right, so Jupyter Notebooks, really good example of nice visual outputs. Observable is the same kind of thing. Alright, but anyway, I am going to see what I can do. With a few more. Well, that's confusing looking, but that's okay. All right. There we go. I'm happy with myself that I've got a SVG mesh wireframe viewer that is just derived from exactly the same parametric data that I use for this. Good luck with your interview. Thanks, C-Films. I appreciate that. Yeah, I hope it goes well. I'm gonna, after this stream, just kind of make sure my computer's working fine, is the right stuff installed, that my Emacs setup makes sense. And I'm gonna write down a few things about, well, just write down a few things that I know, a few things that I am confident are useful, and my thoughts, just so my head's not, just so I'm not like freaking out during the interview, that kind of thing. Is it a Clojure position? Yes, it is, or at least potentially partly. So the details of which language, presumably, I'm looking at the back end positions, and they are, as far as I can tell, Clojure back end positions. I mean, I have no idea if it might evolve into some other languages as time goes on, but yes, Clojure dev. So I'm happy about that, because it is what I'm most comfortable in by a long shot. Okay, so let's do this as I think, oh, I did something wrong there. Uh-oh, wait, is everything still streaming? Okay, yeah, it is. Okay, right, so what just happened there? Let's do this. I'm not sure if this is the right term, if UV mapping is the right term for it. UV space to world space. UV to world. Sure, why not? Okay, so let's start with excuse me. Whew. me think about how exactly I want to do this. First of all, let's just build a surface that let's build a target surface. The bottom is going to be a circle, the radius of 3 times 25.4, and then the top is P circle. I have to do it slightly differently though. P circle, yeah, times 2.5, like that. And here, what I have to do is yeah, that'll work. Excuse me. Lift curve to 3D. Is that? Yeah. Oop, which I actually don't need to put in parens at all. So it's a 3D circle now, and now I do brep/translate, and I want to just translate it up 7 inches, I guess. Seems appropriate. Seems like that'll work. Okay, so that's the top curve, right? So then the target surface is just gonna be the returning, if I just return surface BT, okay, that should be a surface. Now if I do tools, cider, show, SVG surface of target surface, given a segment size of 30. Oh, did I not? Oh, target surf, not surface. My bad. There we go. So it's like a cylinder sort of thing. Looks pretty good. Right, so the name of the game here the next thing, target surface, let's do def wrap sketch. Let's see. I mean, let's start with something super simple. I would like to do let's just make it a set of points. and then the view box will be the thing I define around it, I guess. It's kind of what I think makes sense. Yeah. We'll start with just a set of points. So the oops, that's not what I meant. Yeah, okay. So it's a very simple sketch. And what I need to do is have it, I want to project it, well, not project, that's the wrong word. I want to transform it through the UV coordinates here to get the final point positions. Yeah, so to do that, let's start with this, okay, and we'll do P, polygon. I think that should work. Yes, okay. So there's a few issues with how I'm doing this at the moment, but I have methods where I think I might be able to figure it out. So, well, let's just do, oops. What should I call this function? Something like that. So we've got let's give it, let's assume it's a yeah, I'll call it a sketch, I guess, and then the surface. And then what I'll do here is create, so it's a two-way, yeah, okay. So if I do, let me see, bounds of points. Let's not do this right now. I'll add the machinery later. What I want, okay, so I'll make it like this. Sketch surface and view box is like X, Y, width, height, like this. Is this smart? It might not be smart. We're doing the simplest possible thing first, and we're building off of that. That's the idea. Curve on surface. Okay. Let's not even curve on surface. Okay. Right. The yeah. Yeah, so given a curve and given a surface, the result is going to be apply surface to the result of curve T. But when it has to be a planar curve, so it should fail. Yeah. Hmm. Is this a useful thing? I'm not sure this is a useful function, really. Let's not worry about it. Let's do it. Just check it here. Right, so when equals 3, count curve 0.5, then you can run this function, otherwise it nils. Just wait, no, it has to be 2. It's got to be planar. Then you can apply surface to curve of T to get your 3D curve from that. So, okay, so let's try that. Ay, ay, ay. Okay, so here, let's let's group. And what I want to see is actually the result of, first of all, I actually want two like this. So first I'm gonna map wrap sketch and draw that. And then the second one I'm gonna do map def wrapped sketch is going to be curve on surface, where I give it the curve wrap sketch and the surface target surf. Okay, let's try that. And then here we do wrapped sketch like that. Let's see if that does what I want it to do. Not really. It looks very cool and is very wrong. Let's see what I've done wrong. Oh, I know. Okay, here's what's going on. If I change wrap sketch, if I give it a radius instead of 20, I give it, let's say 0.4. There we go. Okay, so we've got the sketch wrapped around. It looks super weird, but that is correct. And it's too small to see it properly here, so I haven't scaled it properly. So that's kind of the thing that I need to auto scale things to be whatever the size of the sketch is, the bounds of it, I need to scale it to fit inside a UV grid going from 0 to 1 in X and 0 to 1 in Y. That's kind of the idea that I need. Because if I make this, let's say, what if I make it 1? What does that look like? It like twists around itself a whole lot. I should probably let's not do this. Let's get rid of that. Let's render into here. Let's do that. Okay, so this is actually this. Oh, let's also turn off edges. Okay, so that, there we go. That's kind of what we're dealing with here. Oh yeah, of course I do. Right. So for this to work the way I kind of want it to, I do also have to do this. P translate 0.5 like that. There we go. So at least we're in the right. We're in the middle of the UV wrapping. We're not at the bottom corner of it. So that's correct. Just trying to think through what I actually want to try accomplish here. Well, there is a scale function. That's cool. Let me see. Let me mess around with this now. If I look at the sketch, the wrap sketch here, so I've got some basic shape, turn it into a curve, then I'm translating it to the center point, and now I'm gonna do P scale. I want to scale like that and see if it'll actually look right, or if it'll start to work. It's pretty good. Pretty cool. That worked out actually a lot better than I expected it to. So it looks visually a little more correct with some manual scale correction there. But of course that scale is actually, it's totally dependent on, like how good it looks is completely dependent on the dimensions of the target surfaces itself, right? Like this now flares it quite a bit and changes the stretch appearance of it, right? So that's not exactly a picture perfect approach. It's pretty good though. Pretty cool though, I mean. It's like definitely a step in the right direction. I'm gonna go to the bathroom though, I'll be right back. Okay. How do you maintain an approximate aspect ratio? You need to get an arc length, don't you? And I can only estimate arc lengths. I'm realizing this might not be a perfect solution. U curve is going to be excuse me. Let's do fast arc length. Quick arc length, fast. Clojure script have pmap? I don't remember. I kind of don't think so. And if it does, it's like kind of fake. Map, ink, range 10. Does pmap? Ah, right. Let's not worry about that then. Let's just do map curve over range 0 to 1, step size 0.05, so it doesn't take too long. It's gonna be bad, but it's just gonna be close enough, really, I guess. Right, and so the aspect ratio of like 16 by 9, if I think about that, that's the length over the height. 16 by 9, yeah, so it's L over H, so it's like this. It's divided, it's fast arc length of UC over fast arc length of VC. Alright, let's see. Okay, so if I do aspect ratio of target surf, ooh, what did I do wrong here? That's kind of weird, but let's just not worry about that for now. Oh, of course, this is obviously not going to do what I want it to. I need to do... Right, let's change this. Let points be curve... No, map curve over range 0 to 1, 0.05. Same thing. And then actually... Right, then... then points is concat points with first points, like that. Wait, do I need that? Do I care? No. It's really rough and ready. Yeah, so it's actually what I actually want to do is reduce plus with map distance apply distance to partition to 1 of points, like this. Now we should be able to try that, so let's do There we go. Okay, so the one problem with this approach, if I were to change this to use the other bound curve at the top of that shape, wait a second, why is that? Oh, I thought it would produce a different result, shouldn't it? What am I missing here? I'm a little bit surprised by that. Let me think about this. Oh, right. So this almost certainly will produce a different result now. Yeah, and that's way off. So, well, I mean, it's way off from the aspect ratio computed in the other direction. So, what's the right thing to do? Because the aspect ratio it's not continuous, or pardon me, it's not constant. Like, what does an aspect ratio mean? What's the right approach? Okay, here's what I think makes the most sense. Is to not worry about this, but instead produce curve on surface with a bounding box situation like this. Okay. So now what I do is, when it's a 2D curve, then we're good. Then what I actually want to do here is provide, let's see, what I have to do is, it's a function of t, where t is the curve, but I have to transform the curve first, like this. So I have to do, well actually, sorry, let's do it like this. When that's true, then you let the new curve, xf curve is gonna be, you run curve through, still needs to be two-dimensional, so we can do P, parametric from the SVG library, translate, negative, you're gonna translate a negative x, negative y, to move it to that, to move that bounding box corner position into the right spot relative. But shouldn't you first scale? Is that true? The scale is going to be whatever the width is. So it's got to be, it always has to map it into the range 0 to 1. So your scale is going to be calculated as 1 over your width, because 1 is the max, and that's also true. So it's going to be scale 1 over width, 1 over height. And then translate. So I think that makes sense. Let's do it. I think that is right. We'll find out. It's a nice thing about programming is you don't, if you're thinking through it in approximately the right way, you don't have to necessarily worry right away. I don't know what I'm talking about. Okay, so but then what you have is a function of t where the result is apply surface. No, wait. Yes. Yeah, apply surface to the result of xf curve at t. There we go. Okay, let's try that. Now, wrapped sketch. Let's ignore, let's just get rid of all that. We'll call wrap sketch show 2D of wrap sketch. Oh, it's very small. Let's make it 20. Okay, there we go. Okay. Whew. Boy, oh boy. Then wrapped sketch is now curve on surface, where you wrap sketch, target surf, and then you have to provide these positions. Let's do -20, -20, and then the width and height is going to be 40, 40. Let's see if this works. Not quite. As in, and when I mean not quite, I mean not at all. Okay, it looks like the scale is approximately correct. But let's do this first. see if I get this correct here. Oh, this should actually be I'm not sure. Yeah, that's clearly not the right approach. Let's see. Okay, so if I've got something centered at the 0, 0 origin, and my view box starts at negative 20, negative 20, I want the apparent sort of position for the new thing to be at positive 20, positive 20. So what I have to do is translate by negative that is correct, but I have to do it like this. I have to do it after the scale. Well, I shouldn't have to do it after the scale, but I'm gonna give it a shot. Well, let's do this. X, we'll do, okay, negative 1 times X times 1.0 over W. Same for this. Negative 1 times Y times 1.0 over H. Is this gonna be right? Kinda, mostly. I mean, yeah, that is correct. Okay. All right. I don't love it necessarily, but it is working the way I expect it to. That's a good thing. All right. So now what I think I should be able to do is kind of adjust things this way. If I change the bounding box, that's the wrong one. But actually, let's do that. Like this. There, okay. That's pretty good. So what I can do now is, at the very least, I can map something. I can, by adjusting the sort of view box positioning, I can better manipulate how curves get mapped onto their surfaces. So that's pretty good. I think that's probably a smart way to do the interface here. Do I love it? Not necessarily, but I mean, okay, so it goes. Oh, oh boy. Excuse me. Okay. I am gonna go soon, but now let's have a little bit of a think about. I mean, at the very least, okay, there's something I should probably adjust in dev svg. If I go into parametric, polyline, and polygon, excuse me. I have this concept I should probably start to capture in here where it's like, required T inputs. So, how do I do it? Corners, vertices, something like that, vertex parameters. And what you do is say, given, so for polyline, the vertex parameters are going to be, let's imagine a polyline with 1, 2, 3, 4 vertices, right? Then that just means there's 1, 2, 3 line segments in this case. Your first vertex is at 0, your last vertex is at 1. And it's going to be 1 divided by n vertices, right? So n vertices is 4, so we've got 1 over 4 should get us exactly, in theory, the position. Let's see if that makes sense. Let me do it manually here. So let's def b is p polyline. Polyline, and we'll do 0, 0, 10, 20, 30, 40, 50, 60, like that. It doesn't matter what, they're just points. So if I do B0, it gets me exactly 0, 0. If I do B1, it gets me 50, 60. But if I do B, so it's 4 points. So if I do B 1/4, 0.25. Now, why is that? This is, of course, right. It's not gonna be exactly that because I've actually readjusted the T parameters according to the remap based on the length of each segment. So that does in fact mean that each parameter in this case is provided by map2. Let me see. Map second over the intervals, right? Because I think that's right. Let me see. Let's try that. Map v second over intervals. Like that. Let's give that a try. Oh, yeah. Okay, now let me try this again. Let's def B, not as P polyline, but as local polyline here. Okay, so if I run B without, okay, so if I do, yeah. So if I run, it should be concat like this, but anyway, that's fine. If I run map B over vertex parameters from B, I get back 10, 20, 30, 40, 50, 60. That is exactly right. Okay, that is a useful thing to have. So vertex parameters is like basically you always want to map it. Yeah. Okay, that's, what am I saying? That guarantees that we can always get back exactly the corner points, and we could take any parametric polyline or polygon and back convert it into its constituent points. You can do that by pulling the input as well, but if you want to be able to capture the points in a transformation process and keep it parametric, you will need vertex parameters. So that's exactly what we want to see. And that should work without change, I think, for the polygon situation as well. So let's try that like this. So this is maybe sloppy. Well, no, I won't say it that way. This is prototyping in a pretty open way. Every time I figure out something like this, this helps me discover the full definition of what I need a parametric curve function to do. I need, if I'm gonna build a bunch of curve helping functions, curve building functions, I need them all to follow a consistent thing so that I can build on them all as equal building blocks. And the zero arity approach here is useful, but I need to make sure that I can reliably build if I know I need the length of it for some contexts, I need to be able to define length for all of the curve functions. and it's just really cool to, as I'm piecing together more and more utility for surfaces and volumes and stuff like that, I just kind of discover new requirements for the data structure, which I gotta say is pretty cool. So I'm kind of slowly evolving the definition of what a parametric curve will look like in both my SVG and my Forge libraries, 2D, 3D. And I am hoping I can similarly do the same thing with the surfaces approach. Since basically curves are the building blocks for surfaces, I feel like it's inevitable that that'll work that way. So that's pretty good. Okay, I gotta go soon, but this feels correct to me. Okay, I think that's fine. Hopefully. Okay, I kind of think I should just go because I'm pretty slow today, honestly. Not getting a ton done here. Yeah, you know what? I'm just gonna call it today. It's been a real slow day for me. Thanks, people who've tuned in. I do appreciate that. I've just got a lot on my mind. Gotta prepare for an interview for tomorrow. I don't really have any useful commentary for what's going through my head right now. I'm just trying to think through exactly what I need to do next, how I need to, like, what I want to achieve with the next steps for these sorts of things, and just figure things out from there. Basically, I don't know exactly what to do next. That's the simplest way I can describe it. But I'm sure I'll get there, but I'm going to do it offline. So thanks everyone, and I'll be back. I should be back streaming on Thursday. But for now, I'm going to get going. Bye-bye.